Some values for the function f of x equals log x are given in table 1. Here's table 1. And table 2 reverses these things. Okay? In other words, in table 2, instead of x being 10 and f of x being 1, we take the inverse of it. Okay? We reverse these things. Okay? All right? Now the log of 100 is 2 because it's 10 squared, isn't it? Okay? So look, it has 2 zeros, so I have 2 here. And it has 1 0, so there's a 1. If we flip these numbers around, we'll get table 2. So 1,000 is 10 cubed, which is 10 times 10 times 10. So the log of 1,000 is 3. And we flip these around. For 10,000, we have a 4, and 4 and 10,000. Okay, now, this looks like, if this is table 2, this is the inverse of the first table, isn't it? So if the first table is found by the log of x, then we want to know what is the inverse of the log of x. That's what this question is asking for. What's the inverse of the log of x? So that's my question now. Now if I know that f of x equals log of x, I'll write that as y equals log of x. Okay? And if I want the inverse of it, in place of the y, I'll write what? The x. And in place of the x, I'm going to write what? Y. Okay? And so this is the inverse of my original function. The inverse of the log of x. This is the inverse of it. Now I'm going to solve this for y. So if these things are equal, I could let them be the exponent where you have a base of 10. Okay? These things are equal. We're going to say let these be the exponents of this. All right? Where the base is 10 in both cases. So 10 of x now equals, now what is this going to be? This is 10, so the base is 10, and this is the log with a base of 10. Log has, it's understood to be a base of 10, and so you take 10 to the log base 10 y, you're just going to have y, aren't you? Okay, so y equals 10 to the x, and this is the inverse of the log of x.